For 2.8, graphing linear and absolute value inequalities, we're going to do two things. Believe it or not, we're going to graph linear inequalities, and we're going to graph absolute value inequalities. Those are the two objectives for the day. 2.8, let's get into it. So linear inequalities. Okay, these are just essentially lines. They resemble a linear equation, but with an inequality symbol instead of an equal symbol. So you'll remember, hopefully, that if you had something like y, let me get my marker working here, y is equal to 2x plus 1 or something like this, if you were to graph that, you would have a line that starts at 1, and that's going up 2 over 1, right? Up 2 over 1, or down 2, back 1. So we got this line, right? Okay. For today, with a linear inequality, what we're going to do is we're going to say, okay, what happens when, we'll do this one in red, y is less than, the y values are less than 2x plus 1. If that's the case, what we're saying is we're looking for all the y values. Again, this is the y, right? So anything up or down, so this in this case down because it's underneath, right? Y value is less than this line. Okay, so we're going to begin by doing exactly what we did here. All right, so we have this dot instead of a solid line, since this is not or equal to. Okay, it's less than. It doesn't mean or equal to. It just says less than. We would have a dotted line here instead of a solid line. And we'll do a lot more of these, so don't worry if you don't get this right now. And then it says the y values are less than this line. So this is a shading of all of this. All of this shading, along with that dotted line, is your answer. These are all possibilities. To the point where I should be able to take any point I want, right? So maybe I'll take that point, which is, I don't know, we can call it 2, -2, something like that. Okay. If I plugged in the point 2, -2 for x, comma, y into my inequality, it should actually make sense since it's shaded. So if I do that, if I plug it in here, I would get -2 is less than 2 times 2 plus 1. Okay, and that should be a true statement, and it is. -2 is less than 5, right? So there we go. That is kind of where we're going with linear inequalities. Oh, and look, there's an example that was much nicer than the one I just drew, but that's okay. So notice they did the same thing here where they graphed the line y is equal to, although they did a dotted line there, right? -3x minus 2. And then they said, all right, what does this look like if y is greater than -3x minus 2? So here's a greater than example. When it's greater than, it's above the line. All right, so it's sometimes, as this line gets steeper, you guys, it's harder and harder to tell which one's above, which one's below. But it should always have a slope. And if it's sloping down from left to right, it's going to be on the right side. If it's sloping up from left to right, it's going to be on the left side of the line. All right, so just think above the line when it's greater than. All right, so here, let's graph one. It says graph 3x plus 1/2 y is less than 2. So this is in a different form than y equals mx plus b, slope-intercept form. But we can actually use it, okay, and graph just this line. But remember that equals is not what we're really doing here. It's really less than. Okay, so we can get the line here, by plugging in zeros for the other. Like we can plug a 0 in for x, figure out what y is, plug a 0 in for y, figure out what x is. But then we have to really be careful because this inequality here. So what I'm going to encourage you to do, instead of plugging in zeros like we typically do, I'm going to encourage you guys to actually solve this and put it into slope-intercept form. Okay, so let's do that really quick here. Let's get rid of that 3x from both sides so that we have 1/2 y is less than -3x plus 2. All right, and then I'm going to multiply everything by 2, right? So y is less than negative 6x plus 4. Remember that the only time we flip an inequality, which will sometimes happen here, is when this is a negative. All right, so it's not right now, so I'm not going to put that in there to confuse anyone. But if you were to multiply or divide across the inequality with a negative number, then that would have to flip, because when you go into the negative realm, the bigger number is actually the smaller number. Important to remember. Okay, so let's now graph this thing. So we're at positive 4 here. Our slope is negative 6, so we're going to go down 6 over 1. All right, so we have this line. Here's 2 points that we can use. It's going to be dotted. All right, so we're going to dot the line. Okay, and then it's saying y values are less than the line. Okay, so less than is going to be on this side. Think underneath. And if you wanted to check something, you could check something really simple. You could check 0, 0, actually, because 0, 0 should be working. So if you plugged a 0 in for x and a 0 in for y, that's really something easy to plug in. You would get 0 plus 0 is less than 2. Is 0 less than 2? Yes, it is. So I know the point 0, 0 is part of my answer. Right? So I'm just checking to see if that's part of the shaded region that should be shaded. Okay. All right, so that's 1a. Here's 1b. So again, I'm going to have you solve for y here. So 2y is greater than, I'm going to add x to both sides, right? So this will be x plus 4. And then we're going to divide everything by 2. So y is greater than x over 2, which I'm going to change that a little bit, you guys, if you don't mind. It's the same thing as 1/2 x. Right? And then 4 divided by 2 is just 2. So for 1b, we're going to start at positive 2, and our slope is a half. So we're going to up 1 over 2, back down 1, back 2, or to the left 2. Okay, so now what I'm going to do is I'm going to dot my line through there, because this is not or equal to, right? It's an inequality. And what this is saying is we're looking for y values that are greater than this line, so above. And again, you could choose a point that's in there, plug it in, make sure that it works. I encourage you to do that, especially on your test, but I'm going to keep cruising here for the sake of time. So manual here on example 2 has $15 to spend at the county fair. The fair costs $5 for admission, 75 cents for each ride, and 25 cents for each game. Write an inequality and draw a graph that represents the number of rides and games that manual can buy. Okay, so a couple ways that we could think about this. All right, so first of all, we know a couple of things. We know that he has $15 off the top, but he has to get rid of 5 to get in. Right, so it costs $5 just to get in. So what we can really work with here, because we're trying to figure out how much he kind of has left to spend for the rest. So I can do this math before I even write my equation. Basically, I have $10 left, right? So the rides plus the games have to equal or be less than or equal to $10. All right, so when you just say that out loud, you can almost envision the equation or the inequality that you're going to need for this. So the rides, which is 0.75, we'll call it R for rides, plus the games, 0.25 times the number of games they play, is less than or equal to, because you could spend all of it, $10. Okay, so there's an inequality that you can use. In this case, it doesn't really matter here, like what's x and what's y, right? Because neither one of these are really dependent on the other. And I think the way that I graph this thing out, I don't think that it should matter. So what I'm going to do is I'm just going to make g my y. Okay, so I'm going to make g kind of act as like my y. So if I want to put this into y equals mx plus b form, I'm going to solve for g. Okay, so that's what I'm going to do. So let's move our r over. So we have 0.25g is less than or equal to negative 0.75 r plus 10. And then I got to get rid of this 0.25 here. So what I could do is I could divide everything by 0.25, which is the same thing as multiplying by 4, right? So if I multiplied everything by 4, that would make this whole thing go away here. So let's just do times 4. Sorry, it looks like 0.4. You're not supposed to use an x in algebra, but whatever. Times 4, times 4, times 4. Okay, so if I do that, what I'm left with is here, this just goes away. G is less than or equal to, if I multiply negative 0.75 times 4, well, 0.75 doubled is 1.5, double that again, you get 3, right? So this is negative 3r minus, sorry, I shouldn't say minus, plus 10 times 4 is 40. Okay, so here's a line. Again, that's if we solve for g, right? So we're making g the dependent variable. Okay, so let's just do this. Let's make this this line here. So we're going to start at 40, right? That's our y-intercept. And then we're going to go down 3 over 1. You can also say that you're going down 30 over 10, right? Because down 3 over 1 is the same relationship as down 30 over 10. If you take 30 and divide it by 10, that's equal to 3, right? So this is an equivalent slope, all right? You can always do that. Or you can sit there and do the 3, but on this graph it would just be kind of hard. So negative 30, we're going to go down 30 to right in there, down to the 10. Okay, and then we're going to go over 10 to there. Once you have 2 points, that's really all you need. Okay, this is an or equal to, so this is actually going to be a solid line. Okay, solid line. I might want to know where that thing crosses my x here. For some reason, they're not letting me draw over there. Weird. Maybe if I switch colors. I don't know. For some reason, I can't draw all of a sudden. Okay. See if we can figure this out. There we go. Okay, sorry for that, guys. So let's figure out where it crosses the x. So to do that, we just got to plug a 0 in for y, right? So if I plug a 0 in for y, which in this case is g, I could say, okay, 0 is less than or equal to negative 3r plus 40. Move my 40 to the other side, so I get negative 40 is less than or equal to negative 3r. Okay, and then I got to divide by negative 3. So remember, I've got to flip my inequality there, but it doesn't really matter because I'm just trying to figure out where it happens. But it's essentially happening at negative 40 divided by negative 3. Okay, so if I take my trusty calculator and divide that out, 40 divided by 3 gives me 13.33333, so that would mean we're at 13 1/3. Okay, so this comes right down into, just in case we need to kind of know where that happens, that's 13 1/3. Okay, that's where we're going. All right, so they wanted us to just write an inequality and then draw a graph that represents the number that he can buy. Now, in your textbooks, when you're doing a problem like this, they might ask, what's one possibility of, tickets versus games that he could have? Okay, so you got to remember what each thing represents. So on our graph, we turned y into games, right? This is the games axis, and this is the rides. Okay, so if I said he played, 20 games, which is right in here, okay, he could have played as many as, you'd have to figure out exactly where that happens, but you could say one possibility is, it looks like definitely it's less than 5, is 20 games, 5 rides, right? So 20 games and 5 rides would be a possibility. Anything that's in here is a possibility. You don't want to go into the negative because you can't have negative games or negative rides, right? So it would just be anywhere in that triangle is a possibility. including 0. Like, he didn't have to buy anything. He could have just walked around the fair, right? So 0, 0 is actually a very real possibility. Anyway, that's number 2. Let's go on to number 3. It says graph y is less than or equal to 2 times the absolute value of x plus 3. Okay, so for this one, what we have to do is we have an absolute value function here, so we need to plug in. What I encourage you to do is plug in values for into a table to figure out what happens here. So if I love to plug in -2, -1, 0, 1, 2, just because they're easy. So if I do that here, if I put a -2 into that absolute value -2 is 2. 2 times 2 is 4. 4 plus 3 is 7. Okay, if I plug a -1 in, I get 1. 1 times 2 is 1. Is 2. 2 plus 3 is 5. If I plug a 0 in, I get just 3, because that whole thing goes away. And then at 1, I get the same thing as I did at -1, which is 5. And then at 2, I get 7, right? So I'm getting that V shape going. Okay, so let's just first of all get that thing down. So let's do some of these points. -2, 7, 4, 5, 6. Looks like I went too far. That's okay. And then -1, 5. And then 0, 3. And then 1, 5. There's my V shape, which is what I need. I need to go until I get that V shape. Okay, so I have this V shape. Now before I connect it, I want to look here. This is an inequality, right? So in this case, it says or equal to. So it's going to be solid line. If it didn't say that, I would be drawing dotted lines for this V. Okay, so we have this guy happening. And then it's saying the y values are less than that. Okay, so to me, less than means underneath. All right, if you want to make sure that that worked, again, the easiest point that you can plug in, you guys, is 0, 0. If you plug in a 0 for x and a 0 for y, you would end up getting 0 is less than or equal to, this would go away, this would go away, 3. And is 0 less than or equal to 3? It is, therefore that should be part of the shading, and we're in luck. Okay, so that's 3A. 3B, one more for you guys, and then you guys are on your own here. Again, for this one, I would go ahead and make one of my tables here, -2, -1, 0, 1, 2. If you plug a -2 into that, you get 3. Plug a -1 in, you get 0. If you plug a 0 in, you get 3. Plug a 1 in, you get 6. Plug a 2 in, you get 9. Okay? Hopefully you can figure that math out. I'm just speeding up for time. So once I plug that in, -2, 3 is here. -1, 0 is here. 0, 3 is here. And then 1, 6 is up here. And then 2, 9. So I kind of get an idea of what's happening. Again, this is an or equal to. I wish they did one that wasn't, because there would be a dotted line. We can just make it, you know, if there was no line under here. Okay, if there was no line under there, it would just be dotted, right? I'm not going to dot it here because I don't want people to get confused, because the example that's in your notes is probably solid. If it's solid, okay, unless you want that example in your notes, you can change it, okay? But, if it has a line underneath it and it says or equal to, that means we include it and it's solid. Okay, so in this case it actually is solid, but if you want an example in your notes that's not, you can, you know, modify that all you want. And then for this one, it's saying that the values are greater than, the y values are greater than this absolute value line. So to me, that greater than means it's in here, right? Hey, I should have been using that all along for my shading. Okay, so if you want to make sure that that was true, you can actually still test the point 0, 0, but then it shouldn't work, right? So if I plug a 0, 0 in, it should not work here. 0 is 0 greater than or equal to 3 times 0 plus 1. Okay, that means is 0 greater than or equal to 3 times, essentially this is 1, right? So notice 0 is not greater than or equal to 3. This does not work, which is actually a good thing for our graph because it's happening outside of our shading. So just so you know, you can always just test 0, 0, and then just check to see, is that supposed to be shaded or not. All right, guys, that's it for now. We'll see you guys in